guys, welcome to 3.2, finding the right function for your data. All right, so now you have all of your data nicely organized in spreadsheets like this one. Now what I had done was I had followed some of the links to come to the New York COVID-19 tracker. This is for New York State, and so I had clicked earlier data and I was able to get all of these. And then I changed it to last 7 days and I got that. So I entered all of that into this spreadsheet here. All of that data. And that should say New York State. There we go, New York State data. All right, so it's all there. I'll change that for y'all. So the first step is to finding the right function for your data is to view it in a few different forms. So the first one, we're going to look at a column chart showing the date on the x-axis and the number of cases on the y. And if you look here, I put the date in the left-hand column and the new cases in the right-hand column. So I'm going to go to Insert Chart. And here they have something for me with new cases on the Y, date on the X-axis. But what I'm going to do is I'm going to change that to a column chart. And here, this is another way for me to get a good look at my data. And I can see that I've got a curve here. Now, to add this to your report, you can go down here to the Start menu and just type in SN, and there's my snipping tool. So I grab it, and there's a couple of things you can do in your mode. You can have a free-form snip where you can just kind of go crazy with it, and then that turns up. You can also do a rectangular snip. So when you click New, just a nice little rectangle. Additionally, you can do a window snip. That's probably not going to be helpful for you here. So use one of those to snip your pictures. All right. Now that gives us a nice look at our data. You can see I've got that right here, and you can put that in your report. Now, another thing you're going to want to do is make a scatter plot. So for a scatter plot, you're going to want to make a dummy variable for the date, because if you remember, scatter plots need to be dealing with two quantitative variables. So I'll go here and I'm going to get rid of that guy. And then I'm just going to right click on new cases and insert a column left. I'm going to call this number of days. And I've got my first day, and then just so on and so forth. I'm going to make that 10, not 0. Just going to get those entered in. $29 and $30. $40, $41. All right, so I have 43 data points. What I'll do now is I'll come up here and I'm going to left click on B and drag to C. I've now highlighted these two columns because that's going to let the program know this is what I'm looking at. And again, I'm going to go to Insert Chart. And then I'm going to come over here and I'm going to change. I'm going to scroll down to Scatter Chart. And here we have a nice scatter plot of our data, and it lets us really clearly see that curve. Again, I'm going to grab my snipping tool. I'm going to snip this and put it into my report. And this is a good time once you have these to talk about what you see. We see everything kind of tight here, and then things get loose up here. What do you think could be the cause of that? Is flattening the curve working in some areas? Are we getting incorrect reporting? What does that mean? That's going to be part of your interpretation. All right. So once we have our scatter plot and we've seen what our data looks like, we need to look for distributions that are similar to this, or functions. So I looked and I said, okay, well, I've got maybe something quadratic going on, maybe something exponential, or maybe something logistic. And I've got those three functions written here. The way that we're going to find the curve of best fit, because I'm not sure what technology you have as far as calculators go, we are going, for the first time this year, we are going to use Desmos. So I'm going to open a new tab and type in Desmos, and here is desmos.com/calculator. Okay, so I am going to hit this add item table. All right, so now I'm going to come back to my spreadsheet and I'm going to highlight the numbers only. Don't get your headings in there. And I'm going to copy that and then paste it. And it gave me a different one. Cool. I'm going to get rid of that one. And I'm going to make sure that what I have here is X1 and Y1. So you see here, we've got these same points that we saw from the scatter plot we made in Excel. Now I need to figure out what fits this. So I'm going to try a function. Move my face. Oh, that didn't work. That's fun. Several moments of confusion later. So let me come back over here, move my face, and then go back. All right. So the functions we're going to start with the quadratic one. So here I'm going to type in f of x equals, actually I'm not going to do that because I'm going to do y1. F of x is what I'll put in my paper. But y1, remember I named my list y1 or x1, y1. So y1, now I'm not going to write equals because I'm looking for the curve of best fit. I'm going to approximate. So if you look at your keyboard, right next to the 1, there's a key with a little tilde thing. That's what we want. Y is approximately. And now I need to put in the quadratic function, which is a x1 squared. So you see above the 6, there's a little up, so I'm going to hit Shift 6. So squared. And then I'm going to write plus b x1 plus c. All right, so there is my quadratic curve of best fit for this data. And down here are my r squared value and my parameters. So that means that this quadratic would be negative 4.4347 x squared plus 492.112 x minus 2827.75. So you can grab your snipping tool, take a little snip of that, and then you can put it in your paper if that's the one you're going to use. Now here, I'm going to try all three of these. I've just tried quadratic. I'm going to try exponential and logistic to see which one fits best. So here we go. I've got that r squared of 0.8612. That's not bad. Let's see if we can get better. Next, I'm going to try exponential. So f of x equals a times b to the x. I'm just going to come right in here and get rid of that function and say a times b shift 6, and then it needs to be x1. All right, wow. Okay, there's the exponential curve. Look at r squared, 0.6946. Absolutely not. This is not our guy. Right now, quadratic is looking good. Okay, so I wouldn't bother taking a picture of that because the one you're going to want to include in your final report is the one with the line with the curve of best fit. Let's try logistic, where we have c over 1 plus a times e to the negative bx. So I'm going to type c, and then next to your shift key on the right-hand side of your keyboard is the question mark. Underneath that is a slash like division. I hit that and it gives me a fraction. 1 plus a e shift 6 to the negative bx1. Oh yeah, guys, there's my curve of best fit. This is definitely logistic. And so I want to, yeah, look at that r squared, 0.94. So our function here fits this so well that 94% of the variation in y is explained by the change in x. That's really good. So we grab our parameters here. C is 9,197.62. A is 511.882. And then B is 0.326377. So I'm going to grab my snipping tool and I'm going to get a picture of this whole thing. And then coming back, that's what you're going to want to include. And then you're going to want to include your equation. So here, my equation I've got there and my r squared. Now, all of this is going into your section 3, your analysis. You're not really going to go into detail about what it means. This is just where you're doing your math. So what you're going to do now that you have your curve of best fit is you need to find your rate of change for any given day. So you need to take the derivative of the function. And you might be looking at me like, we did not learn how to find derivatives like this. We did simple derivatives as part of our calculus mini unit. You're correct, which is why I've given you this handy dandy little chart that gives you different functions and then what their derivative or what their gradient function is, so you can just plug in your coefficients. Now, if for some reason you find a different function that fits your curve best and it's not something that we learned how to differentiate during class, go ahead and send me a message and I'll be happy to help you out with finding the derivative of that function. So you're going to want to find that and write that out in your analysis section as well. Good job, guys. All right. Join me next time for 3.3, where we're going to make sense out of all this data. Have a good day.